So for this video you need a piece of blank or squared paper, and you need to start just by drawing out some bags or urns that we're going to draw some marbles from. And we're going to create a probability, three probability events, and we're going to try and calculate those. This is going to be conditional probability, and we're going to generate those random problems using this little game, this method of randomizing the colors that we're going to put into our bags. Okay, so we've got to roll 1 or 2 dice for one color, we've got to roll 2 or 3 dice for another. So let's just start with one dice, just one dice then for this bag here. So if I take a color, we'll use red, roll the dice. Okay, so I've got 2 reds now in my bag. So that's how we start, just populating our first main color. So for our second color, you can choose anything we want. Let's choose green. Green seems to make sense as the opposite color. So we've got to roll 2 or 3. So I'm just going to use 2 dice for this. And I've got 1, 2, 2 add 1, so 3. So I've got 5 altogether. So let's do the same for the next one. This time let's use blue. Okay, so 2 dice. No, just 1 dice for this one. Let's just use 1. Keep it nice and simple. 1, 2, 3, 4 then. And now 2 dice for my second colour. Let's choose a, I don't know, brown. 2 dice for this. Okay, so I've got 1, 2, that's fine. We'll just stick with that. So we've got 2 as our second colour there. Okay, this time then, and to get the most out of this video, you want to follow along yourself, come up with your own percentages. I'm going to roll 2 dice this time, and I've still got just 3, but that will do. I'll stick with 3. 1, 2, 3 purple marbles then in that one. What about my secondary colour? Let's just have grey. Should we have a sort of grey colour? Okay. And this time 3 dice then. Oh, okay. 1, 2, 3, 4, 3 and 4, 7. 1, 2, 3, 4, 5, 6. There we go. What have I got? 6, 7. Okay. Well, that looks a bit healthier. And then for my final one, I'll use, let's say, an orange colour. You could use the same 2 colours. You could have just got, we could just go red, green all the way through, but it doesn't really matter. Okay, so we've got 6 this time. 1, 2, 3, 4, 5, 6 for my primary colour, and my secondary colour, 3 dice. Okay, what should I choose? Let's have that red there, that will do fine. Okay, so actually I've only got 4 on here. I'm going to add 1 more, because otherwise we're going to have the same number of as up there. So I'm going to add 1 more. So you can always fiddle around with these things, you don't have to obey the dice. But it's a way of randomizing it so that you generate problems, you don't have to search the internet for worksheets, and you generate your own problems, it's more fun. Okay, so we've now got our urns filled with these different coloured marbles. Well, finally, what we've got to do is calculate 3 events, both one or no, and I'll show you what that means in a minute. But the important thing is we have to flip a coin. So heads means exactly 1, and tails means at least 1. So I'm going to, okay, so I've got at least, so tails at least, let's write that here, at least And so heads, okay, exactly. Let's just write exactly. Let's just make a little note of it for the moment. Then we've got at least, and oh, okay, exactly. So that's all we need to play the game. Let's move then our rules out of the way for the moment. Next thing we've got to do is just draw a skeleton, some skeleton probability tree diagrams. So always like this. So you've got your first event, your second event, your first event, your second event, first event, your second event. And of course the second event branches twice because it depends on whether you've got a, wait, in this case if we write down what we've got straight away. So we've got here a red, so I'm going to write red on this branch here, and this one is going to be blue, this one's purple, and this one's going to be orange. So when we're filling in fact let's just write down, so that would be not red, not blue, not purple, and not orange. Okay, and on the second event it's going to be the same obviously, so this would be your red branch, not red. This would be red, so this is if you've got no, you didn't get red on the first draw. On the second draw you did get red, then you've got, you didn't get red, and then you didn't get red again, so you just got greens in other words. Okay, so blue, or not blue, blue, not blue, purple, not purple, purple, not purple, or finally orange, not orange, orange, not orange. Okay, so that's filled in the structure. All we've got to do now is work out the probabilities. But remember, we've got to figure out this one at least. So if now we start drawing out what we've got to do. So the probability then that they're both red is the first thing we're going to calculate. The second thing is the probability that at least one will be red. And the third is the probability that there will be no reds at all, that will only pick greens. So if you know how to do this, and you know how to fill in the probability tree diagram, then go ahead, pause the video, and see if you can calculate those probabilities based on the tree diagram you draw. If you're not sure how to do that, just watch me do one, and then pause the video and see if you can complete the second problem, and again check the worked solution as we normally do with these videos. So pause the video if you can work on this one, if not just watch me work it through. Okay, so probability that they're both red then. Probability that they're both red. Well, first of all, we've got to fill in our tree diagram. So we start with our first draw, which is the first fork, if you like, of our probability tree diagram. And there are 2 out of 5 total possibilities. So 2 out of 5 then. That means there are 3 out of 5 possibilities that we won't pick red. So 3 out of 5 that we won't pick red. So not red. And you'll notice that 2 out of 5, 3 out of 5 adds up to 5 out of 5. And so that's a certainty that we're either going to pick a red or a green. Okay? Next branch then. So if we think about, we're going to pick a red, but we're not, with any of these examples, we're not going to replace that red. So it's without replacement. So on this branch here, the red has gone. So what's the probability of picking red again? Well, it can only be 1 out of 4, because 1 of the reds has gone. So we've only got this one, this one, this one, and this one. So it's 1 out of 4, or 1/4. So probability of not picking red now? Well, it must be 3. out of that 4, so the 3 greens that are left, so 3/4. And again, a check. These must add up to 1, so 1/4 plus 3/4 gives us 4/4, which is a certainty. Okay, next bifurcated branch then. So we've got the probability first. We did not pick red on our first draw. So what about on our second draw if we do pick red? Okay, well if we didn't pick red, then we must have picked a green. So we've now got red, red, green, green. So that we pick a red, there are still 2 reds in the urn, so it must be 2. And again, we've already picked a marble, so there's 4 left. So it's out of 4. And there are 2 greens, so green, green, again would be 2 out of 4. Okay, again, add this together. I've got 2 out of 4, add 2 out of 4, 2/4 add 2/4 is 4/4, so that must be correct. Okay, now let's fill in our first probability. What's the probability that both are red? So if you paused the video and answered that correctly, your correct answer should have been, well, at least you should have calculated it like this. We've got only one branch here that will produce both red. So we've got a red and then another red. So it's going to be this top branch here. So it's going to be 2/5. And when we're going across the diagram, then we multiply together so that our probability gets smaller. So the chances of both being red are going to be chances, going to be quite a small chance. So 2 times 1, 2, 5 times 4, 20. You can simplify that down, don't have to, but you could simplify it down to 1/10. Okay? Or 10%. That would also be an acceptable answer. So, probability now of at least 1. Pause the video if you want to give that a go. So, at least 1 means we've got 2 branches where there's exactly 1 here, but 2 reds would also be at least 1. So, it'd be those 3 branches there. So, we've got 2/5 times 1/4, which is, we've already discovered, is 1/10. And then we have to add each of the branches. So we've got 2/5 times 3/4, so that's going to be 6/20 or 3/10. And then this branch here, we've got 3/5 times 2/4, so again that's going to be 6/20 or 3/10. And we can add those together because we've got common denominators. So we've got 1 add 3 is 4, plus 3 is 7/10. Which, if you like to convert to percentages, is 70%. Okay, no reds. Well, no reds is this final branch here, so that's going to be 3/5 times 2/4, and that's going to be 6/20, which is 3/10 or 30%. Okay, so that's the pattern. That's how we fill in these problems. We fill in the tree first of all, and then we fill in the probability, calculate the probabilities of these 3 events. So if you're comfortable with that, happy you understand how to do this and what you're doing exactly, then pause the video at this stage and give it a go. Okay, so we've got to first of all fill in our, we've got to create our problems. So we've got the probability of both blue, probability of exactly one blue, and probability of no blues at all. So probability of both blue, well, we'll go to our tree diagram, start filling in our fractions. So we've got 4 out of 6. So 4 out of 6. So 4, 6. And that means not picking blue is going to be these 2 browns here, so 2 out of 6. Okay, next branch. If we have not replaced our blue, then there are only 3 blues to pick from now, and there are only 5 marbles left in the bag. So 3/5, 2/5 then for this branch. What if we go down this branch? Then we've got, first of all, not a blue, so we picked a brown. If we picked a brown, then we've got 5 left, so out of 5 again, out of 5. But this time we've picked a brown, we've still got 4 blues left in, so if we're still picking from 4 blues, then it's going to be 4/5 probability on this branch here. Okay, and if that's 4/5, this must be 1/5. So that's the probability tree diagram filled in. Now, probability that both are blue then is going to be 4/6 times 3/5. And to make things easier, what you might want to do here is change 4/6 to 2/3. You don't have to. Maths isn't difficult if you do it. 4/6, 6, but it just makes things slightly easier. So 2 times 3, 6, 3 times 5, 15. So 6/15 there, and no need to convert to percentages, but you know, if you wanted to, that would be fine. Exactly 1 then. Again, if you haven't paused so far, pause the video, see if you can give that one a go. So probability of exactly 1 is going to be when you get no blue on the first draw and then 1 blue, or you get a blue on the first draw but you don't on the second, so it would be those 2 branches there. So exactly 1 blue would have to be that branch plus that branch. So we've got 4/6 times 2/5, so we've got 2/3. 2/3 times 2/5. Oops, 2/5 plus this branch here. So 2/6 is 2/6 is 1/3 times 4/5. So what have we got? 2 times 2 is 4, so we've got 4/15, and here we've got 1 times 4 is 4, so we've got 4/15 plus another 4/15, so that's 8/15. So our answer is 8/15. Can't be simplified. This one up here could have been simplified, so if you'd got the answer, divide by 3, so divide 6 by 3 and you get 2, divide 15 by 3 and you get 5. So you could have written 2/5 for that one. This one can't be simplified, so it's 8/15. So finally, what's the probability of not drawing a blue at all? So that's these 2 branches here, which means we've got 2/6. This time I won't simplify, just so we've got that. Just straightforwardly write that down, times 1/5. So I could have done 1/3, but I'll keep it this time as 2/6. So 2/6 times 1/5, and that gives us 2 times 1 is 2, and 6 times 5 is 30. Now it will simplify, and that's 1/15. Okay. So now probability both are going to be purple on this problem, probability of at least one purple, or probability of no purples. Alright, pause the video, see if you can give that a go. So, probability of both purple, so if we go to our tree diagram, we've got the first branch, just probability of drawing a purple then. Is going to be, well, how many have we got? 3 and 4 grey, 7 grey. We've got 10 altogether, so it's going to be out of 10. So out of 10. And we've got 3 chances, so it's 3 out of 10. This branch here then must be 7 out of 10. And now on the second draw, we've already taken a purple on this branch, so we've only got 2 out of 9. Here then must be 7 out of 9. But if we didn't take a purple on the first draw, then we would still have 3 left out of 9, or not purple, 6 out of 9. So, probability that they will both be purple, well, that's going to be 3/10 times 2/9, which is 5/90, which you might want to simplify down to 1/18. Probability of at least one, well, that's going to be this branch, but don't forget this branch, because that's 2. So we've got 2, 1 and 1, all of those fulfill this criterion of at least 1. Okay, so now we've got 3/10 times 2/9, which we've already calculated is 1/18. We could go back to this 5/90, and we may well do, but let's have a look at how the other ones work out. So we've got 3/10 times 7/9, so we've got 3 times 7, which is 21/90. So I will convert this back to 5/90. And now with this final branch, I've got 3 times 7 and 10 times 9 as well, so I've got 21/90 again. So 5 plus 29, 21 plus 21, well, that's going to be 42, add 5, 47/90, and that won't simplify, so that's going to be our answer, 47/90. So finally, probability of no purples at all. Well, that's going to be 7 times 6, so 7/10 times 6/9. 7 6s are 42, so 42/90, which, if you want to simplify, don't have to, especially if you're short of time, there's no need. But we've got 21/45, and that will simplify again because you've got 3 divides into both of these, so you've got 7/15. Okay, so final problem. We've got 1, 2, 3, 4, 5, 6 oranges, and we've got 5 of these other colours, these reds here. So we've got 6 oranges. So we're going to write probability of both orange, probability of exactly one. Whoops, that didn't work out very well. Let's just put the bracket on the end of that. And the probability that we have no oranges at all. So first of all, probability that they're both orange, so orange and orange. We're going to go along this branch here then. So 1, 2, 3, 4, 5, 6. out of how many? 6 out of 11. And so this branch here, probability of no oranges, must be 5/11. Second time we pick an orange, we've already picked one along this branch here, so we must only have 5 oranges and just 10 that are left in the bag. Here we've got then another 5/10, which of course we could simplify to a half, so we might well do that. Now on this branch here we've got oranges. Well, we didn't pick an orange, so we must still have the 6, so we've got 6 out of 10. And here then we must have 4 out of 10, so 4/10. So that's completed the probability tree diagram. Now the probability that they're both orange, well, that's going to be 6 times 5, which is 30. Let's write it out in full. We have before, so let's just keep the same pattern. So we've got 6/11 times 5/10, giving us 30 out of 110, which is 3/11, if you want to simplify. So exactly 1. So exactly 1 is along that branch there, or along that branch there. So we've got 6/5, 6 times 5 is 30, so exactly the same as we had here in fact, so we could immediately write down 3/11. And this branch here is exactly the same, because we've got 5/11 times 6/10, so again it's 5 times 6, which is 30, and 11 times 10, which is 110. So we're also going to have 3/11, which gives us the answer 3 plus 3, 6/11. Okay, probability of no oranges finally. So probability of no oranges, these branches here. So we've got 5/11 times 4/10, and that's 5 times 4, which is 20 over 110, or 2/11 this time. So that completes the practice.